me, and I will see you in the next video. Hi everybody, and welcome to section 1.2, which is data sampling and variation in data and sampling. Yay! I have too much fun doing this. Okay, so 1.2 basically talks about data and data sampling. What are types of data? So data could come from a population or a sample. Remember, we talked about population is like everybody or the bigger, crowd or, population basically that we're talking about, and a sample is a subset of that. Okay, so just in case you forgot. So small letters like X or Y are usually used to represent data values. So most data can be put into these two following categories: qualitative and quantitative. Okay, so you might think like, well, who cares? What's the difference? And let me tell you what the difference is. Well, qualitative data is basically data that is categorical. So, it's data that is the result of either categorizing or describing, properties of a population. So, like, for example, hair color or blood type or ethnic group or the car a person drives or, uh, you know, uh, lots of things. Party affiliation, the street a person lives on. These are all examples of qualitative data. Okay, so think when you hear the word qualitative, you can kind of think of like name. This is a name. This isn't it's usually a word or letters. Um, okay, so that's kind of what you can think of. Now, quantitative, okay, this is like a good way to memorize the difference is, let me just let you into the secret world of mathematics here. We're not super creative when it comes to naming things. We just usually, like 99% of the time, the definition is like boom, right there in the name. Okay, so if you look at the word quantitative, um, what word does it make you think of? Well, of course, it makes you think of quantity, right? And what is quantity? The amount, a number, right? So quantitative data are always numbers. So, that kind of data is the result of counting or measuring. Okay, so you have counting or you have measuring. So here's some examples: amount of money, or the rate of your pulse, or height, or weight, or people living in your town, or number of students who are taking statistics right now. These are all examples of quantitative data, okay? Now, you can have two types within uh, that category of quantitative data. You can either have discrete or continuous. And let me go ahead and explain what each of these two types are, okay? So, discrete. Discrete data is data that is the result of counting. Okay, so when you have data that is countable, data that has, whole numbers, right? So, data that is able to be counted is known as quantitative discrete data. Okay, so let's say, for example, you want to count the number of phone calls you receive each day of the week. You could have 0 phone calls. You could have 1 phone call. You could have 3 phone calls. You don't have 2/7 of a phone call. I mean, it's either you have it or you don't, right? It counts or it doesn't. They're just countable, whole, right? Okay, so that's good. So think about that. And then continuous data, it's also numerical, but it's the result of measuring. Okay, so measuring, when you when you obtain data via measuring, that data is considered quantitative continuous. Okay, so let's say, for example, the weight of something. Let's say you and your friends are carrying backpacks to school. The number of books in the backpack, that's an example of discrete data, and the weights of the backpack are continuous. Why? Because weight is measured. All right, let's continue. So super fun example, okay? So let's say you go to the supermarket and you buy 3 cans of soup of tomato bisque, which is 19 ounces. You buy 14.1 ounces lentil soup and 19 ounces Italian wedding soup. You buy 2 packages of nuts, walnuts, and peanuts. 4 types of vegetables, broccoli, cauliflower, spinach, and carrots, and 2 desserts. So 16 ounces cherry Garcia, and 2 pounds, 32 ounces chocolate chip cookies. I mean, that sounds like super yummy. I'm getting hungry. Okay, so name data sets that are quantitative discrete, quantitative continuous, and qualitative. So if I were you at this time, you could pause it right here and see if you can figure out what in this situation would be considered quantitative discrete, quantitative continuous, and qualitative. So, okay, you're paused, right? And then, so let's go ahead and check our solution, one possible solution at least. Okay, so one possible solution is that you can have and 2 desserts, right? So you have 3 cans of soup. You have 3 cans of soup. You have 2 packages of nuts, right? So you have 3 cans of soup, 2 packages of nuts, 4 kinds of vegetables, and 2 desserts. That's quantitative discrete, right? Because you can count them. Now the weights of the soup, so 19 ounces, 14.1 ounces, 19 ounces, that's quantitative continuous, right? Because we measure weights as precisely as possible. So look, discrete, countable, continuous, measurable, or measured, okay? So if you were talking about types of soups or the types of nuts or types of vegetables and types of desserts, well, that's all qualitative data because we're talking about categorical data here, okay? We're talking about names. So hopefully that's what you got, or you at least were able to name a couple of these. Okay, so let's do another fun example. Okay, so determine the correct data type. So here are a few examples for you. Really make sure you take the time, press pause before you see the solution because it really is beneficial for you. I wish I could be right there with you and telling you, stop, I'm looking at you, I want to see something writing down, but at least just humor me, okay, and just push pause and write down what you think it is. It's okay if it's wrong, okay? Now's the time to try it, make the mistakes, be wrong, because it's how you learn. Like, it's okay to be wrong, So, all right. Anyways, that's enough of that. So let's determine the correct data type, whether quantitative or qualitative, and then let's indicate if it's quantitative. Let's indicate if it's continuous or discrete. Okay. So here's a hint. Data that is discrete or are discrete often start with the words the number of, right? Because you're counting. Okay, so A, the number of pairs of shoes you own. So maybe you could write this down somewhere. I don't know. B, the type of car you drive. C, the distance it is from your home to the nearest grocery store. Okay, the number of classes you take, the type of calculator you use, weights of sumo wrestlers, number of correct answers on a quiz, and then IQ scores, okay? And you may be a little bit on the fence on that, but most of them are pretty easy, right? I mean, remember, discrete quantitative is it countable? Can I count this, right? Okay, so, and then continuous is it measurable? Am I measuring this, okay? And then qualitative is just, is this name or a category, okay? So let's go ahead and look. All right, so if you guessed A, D, and G, that's quantitative discrete, you are correct. C, F, and H are quantitative continuous because they're measured. And then B and E are qualitative or categorical, right? Because B is the type of car, and then E is the type of calculator, right? The answer to that is a name. Okay, all right, cool. Well, hopefully you got most of those right, if not all. And let's continue. Displaying data. So tables are a good way of organizing and displaying data. But graphs can be even more helpful, okay? So there's no strict rules concerning what graphs, okay? So let's look at two types of graphs that are used to display qualitative data are pie charts and bar graphs. So let's say here we have De Anza College and Foothill College, and we're talking about the number of students, full-time, part-time, percent, of students here, okay? So let's look at this the pie chart, okay? So in a pie chart, we have the categories, and they're represented by wedges in a circle, and they're proportional in size to the percent of individuals in each category. What does that mean, proportional in size? Well, okay, let me tell you. So if it's full-time students, there's 40% of the students at De Anza College, 40.9% fine, of the students at De Anza College are full-time. Check out the pie right here. Check out this part right here. This is 40% of the entire thing, okay? And if 59% of students at De Anza are part-timers, that's 59.1% of the pie. You see how it's like over half? And similarly here for Foothill, you see how it's 28% full-time and 71.4% full-time. Cool. Okay, so what if you have something where percentages add up to be more than 100 or less than 100, right? So let's say you have here full-time. The categories are full-time students, students who intend to transfer, and students under age 25. Okay, so let's say in this case, at a certain college, you have here 40.9%. I guess this was De Anza, are full-time, but then 48.6% intend to transfer to a four-year college, and then students under age 25 are 61%. Well, wait a second. If I add all this up, this is 150%. How am I going to show that on a pie chart if a pie chart is one whole? Well, the truth is, you can't. So you need to do something else. This data is best. The data are best shown in a different way. So what is that different way, you ask? I'm glad you asked. And that's a bar graph. Okay, so bar graph is appropriate for something like this because you can compare the relative size of each, right? You cannot really use a pie chart if the percentages add to less than 100 or greater than 100, okay? So pie chart percentages need to add to 100%. Well, why? Because, the whole circle represents 100%, okay? So if you have something that doesn't add up to 100, it's going to be weird. Okay. Anywho, so here you go. So 61% of the students are under age 25. Here, 48.6% intend to transfer. Here, full-time, 40.9%, and then all the students is 100. Okay. Now you might ask, well, how come? Why are they different, and why don't they add up to 100%? Because you could be a student that is under 25 and full-time and intend to transfer. So you see how you could have some overlap here, okay? Sometimes one person could fit more than one category. So, okay, anyways. So continuing with pie charts, the following pie charts have this other or unknown category included because the percentages must add to 100. Okay, so so here it is. You have the ethnicity of students at this college, and it's like all over the place. Here's a 36.1, here's 24.5, 17. There's really no like rhyme or reason about this, right? If you look at, chart B, it's organized by the size. So you have largest, and then next largest, next largest, next largest, next largest, and then tiny. Okay, so this is really more informative than like the first one, You might think like, well, who cares? Well, it's just kind of like an easier way to look at it. And statistics is all about taking data, making it visually interesting to people, writing a report, and convincing your audience of something you want them to know. So the more easily understood, the better. Okay. So similarly here, let's say you have a bar graph. So this first one, you might be like, okay, here it's the same data, but now it's in a bar graph, and it doesn't really look like, okay, cool. We have a lot of Asian people, maybe not that many Native Americans. We definitely have more other, but it's kind of all over the place. But if you do a Pareto chart where the bars are sorted from largest to smallest, you can see clearly, hey, it's okay, these are the orders. This is kind of the distribution of students by ethnicity at the school. So it's kind of more easier to read and interpret. Okay. Okie dokie. So sampling. So let's talk a little bit about sampling and types of sampling. So let's say you want to gather information about everyone, right? And we said already, sometimes it costs too much or it's pretty much impossible. So we use a sample, okay? And the sample should have the same characteristics as the population it's representing. Most statisticians use different methods of random sampling to try to achieve this, okay? So let's talk about the different types. Simple random. Okay, so simple random sampling is like, you need to know this one. We're going to use it a lot. Okay, so it's just basically selecting a random sample. One way to do this is give every member of the population a number, and then we can use a random number generator to select a set of labels, and then these labels identify the members of your sample. So let's show this by example. So let's say Lisa wants to form a 4-person study group in her pre-calculus class, which has 31 members. Okay, so to choose a simple random sample of size 3 from the members of her class, she could take a hat, put all 30 names in it, and shake the hat and close her eyes and pick out the 3 names. Ta-da! That's random, right? There's no way she would have known what would have been in her hand or what she's chosen. So, all right, random. But another way to do this is for Lisa. Let's say Lisa puts the last names of the members of her class along a 2-digit number, and then she uses her calculator. Okay, so this is, let's say these are all the last names. You have Anselmo to Wood, and they're 30. And she associates each one with an ID of 0001 all the way to 30. Okay, and then she uses this function on the TI-84 Plus called randint, random integer. So you can use this function. Let's see. It would be found under, let's see. Nope. Let's see here. It would be found under, I want to say, let's see. No. Let's see. It would be under It would be under math. Okay, so you would hit the math function, the math button on your calculator, and then you would have to select PRB. So math PRB and then rand. Okay, randint. So you would show the lowest number possible, which is 0, the highest number possible, which is 30, and then you say, hey, calculator, pick 4 of them, and then it gives them back to you. So again, if you have your TI-84, you would hit math. So you would hit math, and then, so let me see if I can, so it's math function. Oh, this is terrible. Okay, I'm going to figure out a better way to do this, and then PRB. For those of you out there that are visual learners, this is for you. Please excuse my kindergarten style writing. So it's in your home screen. Click the math button and then hit PRB, and then you hit randint. Okay, that took forever, and I'm sorry. Okay, so stratified sample. To choose a stratified sample, let's divide the population into groups. Okay, also known as strata, and then let's take a proportionate number from each group, each stratum. Okay, so let's say, for example, you could group your college population or stratify by department, and then choose a proportionate simple random sample from each stratum. Okay, so each department to get a stratified random sample. So let's say we have 5 departments and you want to choose a sample of 50. Okay, so let's say you have the math department, the English department, the science department, the art department, the kinesiology department. I don't even know if that's a department, but let's just say it was. So you have these 5 departments, and then from that department, you choose 10 each randomly, okay, within that department. So that's what this means, SRS, simple random sampling. Okay, so that's stratified. Now, cluster is similar to stratified, but different. So make sure you take note of the difference. Okay, so let's say to choose a cluster sample, we take our population and we cluster them, we group them. And then instead of choosing randomly within each group, like inside that group, we choose randomly outside of the group, and we choose one of the whole clusters, and that's the cluster sample. All the members from that group become your new sample. So let's say, for instance, we have, let's say we have our faculty, right? Let's say we have your awesome college faculty, and we divide them each by by department, like all of them, not just some of them. We have all of them. Okay, so let's say we have, let's say altogether we have 20 departments. I don't know. Let's just say and each department would be a cluster. Okay, so let's say we give each department a number. Okay, so, 1 through 20 or what have you. And then we choose 4 different numbers from that using our calculator or names from a hat or whatever, or numbers from a hat or whatever, random. Okay, and then now my cluster sample will be all the 4 departments. Like everybody that works in that department is part of my sample now, because I've chosen a group of groups, right? So I have a cluster sample. So that's a cluster sample. Then we have here systematic sampling. Okay, so systematic sampling means you basically pick a starting point and then you take every nth piece of data from that listing. Okay, so one way to do this, if we were in class physically and I could see all of your beautiful faces, and we had let's say we have a classroom with 35 people in it, I would say, okay, start with seat number 6. Okay, so seat number 6, let's say we were all seated in rows. And then from then on, I would pick every 5th person, just, systematically, orderly. Okay, so when it says nth piece, it means every 5th, every 100, every 1000th, whatever, but that's consistent. So if I was in a classroom where everybody's seated looking towards the front, like lecture style or what have you, and I say, okay, we're going to start with number 6, but then after that, we're going to go every 5th person is going to become part of my sample. And then we count, blah, 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 to the 11th person, blah, 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 to the 16th person, blah, 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 and then all those students selected that, step up and become part of my sample, that's a systemic sample. That's an example of that. Okay, but, just try to visualize it because we're not in person. So, but here's another one. So let's say you have to do a phone survey, and this is really old school. Sometimes this book has really old examples, so you'll forgive me. A phone book is something we used to have. The white pages or the yellow pages. For us older people, we know what they are. For you younger people, it's a thing that used to exist, or it maybe still does, who knows. But let's say your phone book, it contains 20,000 residence listings, and you want to choose 400 names. Okay, so out of 20,000 people, let's say, I know, phone book, it's crazy. It's a book with phone numbers just listed. I know, it sounds like I'm over-explaining, but it's really funny. Okay, so anyway, let's number that population 1 to 20,000, and then we'll use a simple random sample, right, to pick a number. We'll randomly pick a number that represents the first name in that sample. So let's say we start with 597, for instance, whatever, random, okay? Then after that, that's my starting point. Then after that, I choose every 50th name afterwards. Okay, so if I started at 597, what's my next one? 647. And then the next one would be the 697th person. And the next one would be the 747th person, me wishing I picked an easier number. But you get what I'm saying? It would keep going. And then even once it reached past the 20,000 mark, it would keep going like in a circle. It would start all over again, okay? So you would have to keep going until you have a total of 400, okay? So that's systematic. It's frequently chosen because it's pretty simple. Okay, so all right. So so those are the types of sampling. And now let's go into replacement or without replacement. Okay, so what is to sample with replacement? So true random sampling, like really random, it's done with replacement. So what that means is once you pick a member, that member goes back into the population and can be chosen more than once. So, however, sometimes simple random sampling is done without replacement. So, like, for example, if you take a survey, that's usually done without replacement, meaning that you only choose the population once. Okay, so most samples are taken from large population anyway, and the sample usually tends to be small in comparison to the population. So since that's the case, sampling without replacement is pretty much the same as with replacement because the chance of picking the same individual more than once with replacement is very low. Why is it very low? Because the population is large. All right. So again, replacement means you pick something, you put it back, you could theoretically pick it again. It goes back in the pool. Like if you draw numbers from a hat, after you chose that little number, you put it back in the hat. We replaced it. Non-replacement would be, okay, I chose a number from a hat and then I kept it outside or I threw it in the trash, whatever, Then my next choice, I couldn't pick that number again because it's not available to me anymore. That's without replacement. Okay, fine. So next, sampling errors and non-sampling errors. So when you analyze data, it's important to be aware of sampling errors and non-sampling errors. Okay, so anytime you sample something, there could be errors. Okay, so there could be mistakes, right? Let's say, for example, your sample's not large enough. Okay, so that could be an error, right? If your sample's not large enough, it may not represent the population accurately. Okay, so another thing is factors that are not related to even the sampling process could cause non-sampling errors, like a device that you're using to count that doesn't work. That could cause a non-sampling error. Okay, so there's always going to be some sampling error. Okay, so technically reality in the actual world, it will never be exactly representative. We try the best we can. We're trying the best we can to get samples that represent everybody, but it's not going to be perfect, right? There's always going to be some kind of error. And it's cool. The cool thing, you can calculate the error. I don't want to get ahead of myself, but we could figure out how much is that error, what type of error. So that's very exciting. But anyway, for now, it's just good that you know what it is, okay, and that you know it exists. And as a rule, if you have a larger sample, the smaller the error. Okay. So this slide has a lot of words. So you may want to pause it and look over it at your leisure because I'm not going to read all of this, right? So let's say, what's the point? We need to consider the statistical studies we read about, okay, critically, and we need to analyze them before we accept the results of the studies, okay? So a lot of times if someone says to you, this is the best hair product available, and this is, it's very tricky, think about it. People have ulterior motives. They want you to believe something. They want you to buy their product. They want you to do this. They want you to do blah, 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 okay? That's just like reality of life. So when you hear of studies show that this, well, don't just take it at face value, make sure that you think about them critically, okay? So like, where is this from? Who's saying this? Who was sampled? What was the study based on? So like, for example, some problems could be that like the sample doesn't represent the population. Is the sample that you've taken really represent everybody. Let's say we go, oh, this medicine, will like make you super thin, and it's a diet pill that works amazingly. It's been studied, and we've tested like 100 people and women, right? Let's say they usually target women, but let's just say, okay, we've tested 100 women and they've all lost 30 pounds. Yeah, but where did you get those women from? What if they got these women who are already like members of a gym, or they were part of some kind of weight loss club, or they were already doing other things that made them lose weight as well? Then yeah, of course they're going to lose weight, but it may not be related to the medicine. You get me? Okay, that's what I'm trying to say. So another thing is self-selected samples. So people who just volunteer for that can be unreliable. If it's too small, it could be unreliable. Let's say, also, how was the sample administered? Like, how did they collect the data? They could have worded it in a way like, yes, you lost weight, right? Or yes, they would never ask if they did anything else other than take the pill. All right. And then who paid for the study? Let's say, like, what if there's a study they say, oh yeah, this medication works to lose weight, and the people that paid for the study are the makers of that medication, and it's just like this big old conspiracy. So I mean, really, of course you're going to want to release a study that makes me want to buy your product. So let's say, like, people can also mislead you by showing you graphs that are not properly displayed, like they don't have all the data. And then, and the last example is confounding, so which is basically what I just said. If you have multiple factors on something that cannot be separated. So you say, okay, yeah, this pill can make you lose. Yeah, these women lost weight on this pill, but they were also working out. They also had a nutritionist. They also had a lot of other weight loss support. So how do you know that it was only that the medication was the only factor? There's not. You can't. There were other things involved. Okay. Yeah. Okay. All right. So let's go through this. We're going to now have a super fun example and an opportunity to see how well you were listening. So let's say here, okay, a study is done to determine the average tuition that San Jose State undergrad students pay per semester. Each student in the sample is asked how much tuition he or she paid for the fall. What's the type of sampling in each case? Okay, so we're going to guess from stratified, systematic, simple random, cluster, or convenience sampling. You have 5 choices. Okay, so A, a sample of 100 undergrad students is taken by organizing the student's name by classification. So they're put into certain groups. And then they select 25 students from each. I don't want to give it away. You have to guess, okay? This is the way it works, okay? You have to try. Okay, so B, a random number generator is used to select a student from the alphabetical listing of all undergrad students in the fall semester. Starting with that student, every 50th student is chosen until 75 students are included in the sample. Does that sound familiar? Have you been taking notes? If you have, could you look back on it? Sure, you have access to this PowerPoint anyway, so go ahead and take a look at that. If you need to go back to, refresh your memory or rewind the video, that's fine. All right. And then C, a random method is used to select 75 students. Each undergrad student has the same probability of being chosen at any stage of the sampling process. D, freshman, sophomore, junior, and senior years are numbered 1, 2, 3, and 4 respectively. A random number generator is used to pick 2 of those years, and all the students in those years are in that sample. So that's something to think about. And then E, an admin assistant is asked to stand in front of the library one Wednesday and to ask the first 100 students that he encounters what they paid for tuition. Those students are the sample, those 100 students. Okay, so here, go ahead and push pause. Okay, write your answer down and So I'm just going to wait until you pause and write your answer down if you haven't already. Okay, and with the assumption that you did pause, remember, please try these. It's good for you. It's like broccoli. It's good for you, good for your brain. All right, so A was stratified, B was systematic, C simple random, D was cluster, and E was convenience. If you got these correct, give yourself a pat on the back. Good job. Okay, yay, you did it. Okay, so that's good. All right, next. So what is variation? Okay, last topic of this section, I promise. Variation is present in any set of data. So what the heck are we talking about variation, right? Something that varies. The definition is in the name. So let's say, for example, you have a beverage that says it's 16 ounces, right? You know, that can could contain more or less than 16 ounces of liquid. Okay, so in one study, 16-ounce cans were measured, and they produced the following amount. So you have 15.8, 16.1, 15.2, 14.8, 15.8, and 15.9, right? So none of these actually are all not 16, right? And it varies because different people make the measurements or because the exact amount was not put in the can. Okay, so manufacturers run tests to determine if the amount of beverage in a 16-ounce can falls within the desired range. I know I've been like kind of upset like when I buy a bag of chips at a vending machine. Don't know if you can relate to this. And you are like, yes, I'm gonna munch on some chips. And you open that bag and like there's 2 chips in there. I'm like, what the heck? Like, why? I just spent $1.25 on this thing for 2 chips. It just doesn't seem fair. Somebody needs to do better quality testing at that company. Okay, so that's like a large variation, you know. All right, so that is it for 1.2. So your super fun homework, okay? So you go to the textbook again, like at the end where it says practice, not the homework section, but the practice section, and go ahead and do section 1.2, 7 through 37 odd in your book, right? Please scan or take a copy, or you can download a scanner on your phone and take a copy and create a PDF, and then upload that to Canvas. Also available on your phone, okay? Shouldn't be too difficult. If you have problems with this, please message me. I will totally walk you through it, or ask me in our Zoom meetings. More than happy to show you how to do this, okay? All right, so that's it for 1.2, and I will see you on the next video. Bye.